All right, so let's do the second half of this lesson. We're going to work on lesson 3.2, which is adding rational numbers together. Okay, we're using the word rational now because we're dealing with positives, negatives, fractions, decimals, and basically any number that can be written as a ratio or as a fraction is a rational number. Okay, so let's look at the first one. If you remember when we were adding integers before, we liked to use lots of modeling. We used counters, number lines, and we even oftentimes applied some context, some real world scenario to go with our numbers. All of those things are very useful, especially now, because we need to be able to make sense of our answers once we solve the problems. So we're going to start this one with a number line. Now we're starting at 2.5, and we're going to add 1.5. Well, I know that my 2.5 can be over here. I don't really need to put the 0 there. I'm starting at 2.5. I'm going to add 1.5. But how should we set up our number line? That's the question. Well, I could go in increments of 1 or halves. It kind of makes sense to me to fill in the 3 to get my whole number, and then 3.5, and then 4, and then 4.5, and I'm going to stop there because I know I'm only adding 1.5 to this. So here we are at 2.5. We're going to add 1.5. Here's 1. Here's a half. We're ending at 4. Now, you may automatically have thought, well, I'm just going to line up my decimals and add these numbers together. This is what's called the algorithm for solving. This is great, but it's very hard to prove your answer if you don't have a model. And this is what helps us really think more deeply about the math that's happening. This is a more abstract kind of shortcut way of doing it. So really, really focus on this because on the assessment you will need to analyze your representations on number lines and things like that. But we can solve it this way and we get 4.0, which is the same as 4, right? Same thing. Okay, let's look at this one. This one we're adding 2 negatives. And if we recall, when we think about this, if we had negative counters and we added more negative counters, we had more negatives, right? We're adding 2 negatives. So we know our answer is going to be negative. Can't possibly go to positive if we have negatives and then more negatives with it, right? But let's look at it in a number line. So let's say we're working with negatives, so I know we're going this way, right? Let's put 0 here. We'll do 1, 2. Now, how do we want to break this up? Our largest fraction, let me rephrase that. Our denominator, that is the largest, is 4. So I think we should split each unit, each whole number into fourths. So we're just going to put precision is important. Okay, so we need 1, 2, 3. That's 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay? We're starting at negative 3/4. So here's 0. Here's 1/4, 2/4, 3/4. Negative 3/4. There we are. We're adding negative 1/2. So we're going backwards 1/2. Okay? Well, these are in fourths, right? So we're going to need 2 fourths to make a half, okay? So we're going to move 2 units, 2 tick marks to the left. This is when we added negative 1/2. Where are we now? Well, we're 1/4 past the negative in the negative direction. So this is going to be negative 1 and 1/4. Okay, now let's solve that again with the algorithm. By the way, notice that I am not converting these fractions to decimals. I'm not changing this to negative 75 hundredths or negative 55 tenths. I'm not doing that, okay? We're going to work with fractions, lots and lots of practice with fractions. We cannot add fractions that have different denominators. So we're going to rewrite this one. And we can double it to get the same, so we're going to have -2/4. Well, -3 plus -2 is -5, and we keep the denominator the same. But wait, we got -1 1/4. Are these the same value? Yeah, because we can simplify this to a mixed number or change this to improper, right? 4 times -1 is -4 plus 1. Well, actually, let's just do it this way. 4 times 1 is 4 plus 1 is 5, and it's a negative, and then fourths. So those are the same. Okay, good. Let's do one more. Here, we are adding different signs, right? This was something that we did in the first module. Different signs, only now we're working with decimals. We're starting with a positive, but we're adding a negative, so we know we're going to move left. So I'm going to put my 4 1/2 over here. I think I'm going to use half increments again because I'm dealing with halves in both numbers. So I'm going to go to, this would be 4, 3.5, 3, 2.5. Remember, we're moving this way towards 0 because this was the bigger side. Okay? Now we're going to take away 2 1/2, right? Subtraction is adding the opposite. We're going to take away 2 1/2. We're here. We're going to take away, how many halves do we need to make 2? We need 4, and then one more. So we're going to go 5 units to the left. 1, 2, 3, 4, 5. Look at that. We end right here at 2. Makes sense, right? 4 1/2 minus 2 1/2 gives us 2.0. Same value. Modeling is key, okay? It proves the work that you're doing in the problem. It allows you to go back and make sense of your answer. And it also allows you to work backwards. So when you're given something that looks like this, or this, or this, or something that looks different, with a number line, you should be able to write what's happening in the problem and what the answer is. You're now going to do some practice problems and then check your answers at the end.